In previous video we have seen the how the steering wheel is connected with the steering column or shaft, and the rotary motion of the steering wheel is transferred into the steering gearbox with the help of the steering rod, and the steering box mm, converts the rotary motion into the swelling motion of this drop arm, and from this drop arm to the drag link to the link rod arm, and link rod arm to the steering knuckle, and up to this part from drop arm to the drag link rod to the link rod arm to the steering knuckle. This part is called as steering linkage. Okay, now we have seen up to the steering knuckle. We have seen how the power or the motion is given up to the steering knuckle. We have seen the steering knuckle is fitted integrally with the wheel axle, and it is forked at the inner side of the wheel. The upper finger of the steering knuckle is connected to the one end of the link rod arm, and other end is connected to the track rod arm. This track rod arm is both the side of the wheels, right and left, both side of the wheels. The track rod arm is there. The rear front axle is fixed. This track rod is having a motion, and this track rod and this form a 4-bar mechanism which allows the wheel spindle to or the wheel assembly to move in the same direction. Because of this, it is possible to achieve this. Okay, and at the track rod arm there is an adjuster. This is the track rod is made up in two halves or two parts, and due to this adjuster it is possible to adjust the slacks in the joints, or if there is asymmetry in the joint, it is adjusted with the help of screw inside the adjusters. And also we can, if there is a misalignment in the linkage, it can also be adjusted with the help of this adjuster. Here in figure we are observing this track rod arm and track rod arm and track rod to the front side of this axle, but in actual practice it is behind the front axle. Okay, this is for understanding or clarity. This book's author has drawn this figure in such a way so that we will understand. Okay, I think this is all about steering system layout, but in exam it is better if the question is asked about the steering system layout, you will draw this figure. This is more simple 2D diagram. You will understand better how the rotary motion of the steering wheel given to the steering shaft and through this gearbox. Again, this rotary motion is converted into swelling motion, and this link rod will reciprocate or linearly motion is given, and with the help ball joint. This is the steering arm, or we can say that steering arm or a link rod arm, and here are the track rod arm. Okay, and due to this track rod assembly, it is possible to turn the vehicle or rotate the vehicle in the same direction, okay, at a time. And this is the fixed axle. In this way the steering will work. Now uh, here also you will look this part or see these parts in 3D. Now we will see in detail the working of the steering box. There are different types of steering boxes. Okay, steering boxes. The main purpose of the steering box is to convert the rotary motion of the steering wheel to a swelling motion. Okay, and the motion is given to the your output shaft of the steering box, that is called as cross shaft. Okay, now we will see the detail of the steering box. Different steering boxes are rack and pinion type steer box, recirculating ball type gearbox, worm and gear sector type gearbox, worm and roller type gearbox, cam type gearbox, and worm and nut type steering gearbox. All these are the different types of steering gear boxes. But the main important steering gearboxes are rack and pinion type and recirculating ball type. First we will see the rack and pinion type steering gearbox. Okay, rack and pinion type steering gearbox. First, this is mainly suited for small and medium size passenger cars. Okay, here the small pinion is attached at the end of the stub shaft, which is connected by means of universal joint to the steering shaft. Okay, and which is at the lower end of the steering shaft. Okay, when the steering shaft rotates, the rotary motion is given to the pinion, and due to this rotation of the pinion, the rack will slide, or it will slide in horizontal direction. The rotary motion is converted into the sliding motion of the rack. Okay, so this even it is possible to, when the steering wheel will be rotated or turn clockwise or anti-clockwise, in the same way the rack will reciprocate it. Okay, here the in figure you will show that it will turn to the right or left motion of the tie rod. Okay, and this tie rods are connected to the steering arm on the wheel spindles, and this pinion is closed in a proper casing over the rack tube, and this pinion shaft is supported in the bearing number 1. Okay, and other end on the bearing number 2. Okay, so that for the adjustment in case of so that it will rotate, and these bearings are, as already discussed, the construction of the shaft and the steering shaft steering rod and the column, how it behaves in case of accident. Okay, so the main important part is the rotary motion of the steering shaft is converted into the reciprocating motion of this rack, and this rack is provided connected to the steering arm on the wheel spindle. Okay, the whole assembly is closed. Okay, so this is about rack and pinion type. It is very simple in construction and working, so that it is mainly preferred in small and medium size passenger cars. Now we will see the second type is recirculating ball type, which is used in a heavy vehicles and large size passenger cars. Okay, at the one end of the gearbox, this is the gearbox, this is the steering rod, and is connected to the worm wheel. Okay, worm wheel which rotates inside a ball nut with a corresponding internal teeth. Here is the worm wheel which rotates. Here we have seen this is the worm, and here is the ball nut or steel balls, and due to this rotation of the shaft, this ball nut will move up and down, and due to this motion of this nut, the gear sector will be rotated, and the swelling motion is given to the cross shaft or the drop arm. Okay, and here the circulating balls are only contacted between the teeth of the nut and those on the worm, and it also reduces the friction in operation and thereby reduces the turning effort required by the driver at the steering wheels. Due to this ball arrangement, the driver will have to have a less reduce the turning effort of the steering wheel. And on its outside showed a ball nut has a teeth, and due to this teeth engages in the gear sector mounted on the cross shaft, and due to which when the steering shaft rotates, the ball nut moves up and down. The external teeth on the ball nut meshing with this gear sector makes the cross shaft turn, and this drop arm or the pitman arm will sway, and this provides necessary downstream movement for steering. This worm is supported on ball bearings at both the ends. The whole arrangement is enclosed in the casing, which has suitable flanges for fixing it properly to the vehicle frame. This is a simple type of gearbox which is mostly used in the heavy vehicles and large vehicles. I think in this small video I have covered two important steering boxes. First is rack and pinion type gearbox, and second is recirculating ball type gearbox. One should understand that the rotary motion of the steering shaft is converted into the swelling motion of the drop arm or the cross shaft, the output of the steering gearbox. And in both the uh,